So here we go. We've just started recording, just so you know. Recap back to page 2 of the booklet. So this was, I just snipped this from page 2 of the booklet. These are the formulas on page something of your formula booklet. Was it page 2?
Well, never mind.
Is it page 3? Thank you, yeah, because I actually forgot myself what it was. These are apparently on page 3 of the formula booklet. We are recording again. Alrighty, so what was I talking about? So this is found on, these are the formulas on page 3 of your formula booklet. They're the things that relate to this whole unit. This is a thing I call the gorgeous formula for finding the binomial coefficient. This one is just explaining what the binomial theorem is in case you forgot. So if it was a plus b to the power of n, why do you think, well, actually it asks us to explain it down here, so maybe I should refer to you more down here. Use the knowledge you gained from the investigation in L1. Explain how the second formula works. So the second formula meaning this one here, which is the second one. How does it work? So a plus b to the power of n. Why do you think this is just a to the n? How come do you think on the first term they don't have any of this business here? Yeah, that's it. That's the reason why. So just demystifying this formula so that if you're required to look at it at all, if you forget how to do binomial theorem, you'll understand what it means. So the first term in any row of Pascal's triangle is always 1. It's always just 1. Hence, why it's, for example, 1 to the n. So no, they don't bother to write the 1.
And any raw?
Row. Yeah.
Oh.
Yeah, that's right. Raw.
Ran.
Does look like raw. Ran, yes. Does look like that. The first term in any row of Pascal's triangle is always just 1. Hence why they just write it as a to the 1. They don't bother writing the brackets n 0. So you can say, no need to write n 0. There's no need to write n0. So that's why in that they don't bother to write, see they start with n1 up to nr. They don't bother to write n0 because n0 is just 1. Same thing that we kind of wrote here is that. So the last term in a row of Pascal's triangle will also always be 1. Hence, no need to write n, because that thing's just always going to equal 1. So same reasoning kind of for both of those. So I'm just giving it a moment. Yeah, same reasoning sort of as for the first one, but it was kind of hard to say the same reasoning as before because it was more to do with n as opposed to n. Sort of noticing what's happening to the powers of a as you go from left to right? Yeah, decreasing by 1, yeah, that kind of thing.
So it's n minus 1 and n minus r?
Yeah, up to n minus r, which is the final one.
Okay.
Yeah, like.
Oh, because it says dot dot dot. Okay.
Yeah, the dot dot dot, that kind of stuff. Yes, exactly. So we don't know where it's going up to, but assuming that it's kind of going up to nr, because the general form of that thing is nr. So you could write something like the powers of a are decreasing from 1, decreasing by 1. from left to right. And similarly, powers of B. Powers of B are increasing. Powers of the second term are increasing by 1. From left to right.
I'm so sorry.
There you go. So there's a lot to write there. So this formula, that's why it's to me it's pretty obvious what that means, but to you that might have seemed a bit weird. So this is just trying to point out that what you do when you do binomial expansion, they've tried to generate a formula to help remind you. In case you had a brain freeze in an exam, and you forgot how to do binomial expansion, so it might trigger some kind of memory. But we need to make sure that you understand what it all means first.
So when do you reckon we'll finish binomials?
No one's mentioned anything about tests or anything coming out.
Because like when school gets off the 15.
Oh yeah, definitely before then. As in like this is L3 and there's only L4 left to go.
Oh.
Yeah, and that's all there is. Yeah, it's not like there's more coming in the unit. It's just L1 to 4 and that's it. So we just give you lots of past exam problems.
Well, we'll start a new topic for.
I don't know actually. We
do another test before.
We'll probably, I'd say there'll definitely be a test for this, but maybe we'll just start a new topic, but we won't have finished it before December break.
Can we have a Christmas party, but like do math and stuff?
Just do that in your easier subject.
How much food everyone brings in and like calculate the percentage.
No, it's always in the
Apple pie.
Do it in your other subjects. They're more festive. Your other subjects are more festive. But you know, like just a math food party is always like. It's not as cool. In your other subjects, yeah. So we've sort of demystified that. So this is the way it's presented in your formula booklet. Thank you. Next thing. Below is a formula from the previous page. This is the same formula as before. It's telling you the same thing, but it's explained in a different way. This is not how the formula booklet did it, but this I stole from your textbook. Your textbook offered it in this way, but I thought it's still good kind of trying to get you to demystify what this means because it shows how it relates to sequences and series. Let's see. Does anyone want to suggest what is being said here? Like what's being said here? Yeah, good. So the sum of, that's what that funny signal means. The sum of terms in the binomial expansion. So specifically the word sum was important. What does this funny little bracket tell us? What information is that telling us? It might seem obvious, so feel free to offer anything if you think it's obvious. What are we calculating when we're calculating that thing?
Oh, NCR.
Yeah, exactly. It's NCR, yep. Which is the values from which famous triangle? Yeah, Pascal's triangle. That's what that thing is calculating.
What is that E word?
Oh, that thing? Oh, expansion, yeah. The sum of terms in the binomial expansion is what's written in blue. This funny bracket thing is what we're finding when we're doing now NCR. It might be worth like writing what that formula is. NR equals what goes on the top of the fraction. Good. Over what goes here? Good. Yeah, exactly. That's what it's saying. Like it's the sum of all of these thingies increased. And that's just meaning like powers of A are decreasing from left to right, powers of B are kind of increasing from left to right. That's kind of what it's pointing out. Similar kind of thing. I just wanted to show you how it's presented in a way that's kind of trying to point out, connect it to sequences and series. Starting with R is 0 and N on the top, that kind of thing. Because remember the first one is N n0, and then the last one will be nn, and all the ones in between. That'll do for that. Is anyone still writing that, just in case I don't move down too fast? I found this little picture on the internet. What's the name of... Oh, I gave it away. I was going to say, what's the name of this person? It's kind of... So Isaac Newton. I didn't realise that I'd had it actually written there. Below, who invented the binomial theorem? What does anyone know what other part of our maths course that you haven't kind of formally studied yet Newton's really famous for? Calculus, yep. Where did Newton come from again?
The UK.
UK, yep. UK is very proud of Newton. But no, he's also famous for founding calculus, but also the Germans say that their mathematician Leibniz actually found calculus first. So the conclusion tends to be that both of them found it simultaneously and in different ways. So that's when we get up to calculus. So below, the formula has been presented in a slightly different way. Explain how this thing here, thank you, explain how this thing works for the expansion of 1 plus x to the power of n. Oh, and thanks. So this formula here is showing it in a slightly different way. What have they factored into their formula? But they've kind of made it not with a and b, they made 1 and x. What have they factored into their formula that wasn't in the other ones? Well, x, yeah, you're right, because they didn't use a and b. Yep, so they used 1 and x instead of a and b. What are these things, do you think? Where does it come from? These things come from? I call it the gorgeous formula.
Oh,
Yeah.
binomial coefficient formula.
Yeah, exactly. So in their formula, they're factored in. So in their version, they've replaced the nr thing. They've replaced nr with n factorial over factorial n minus r factorial. So in their version of the formula, they've kind of factored in this kind of business kind of stuff. They've sort of done vaguely. Why is the first term in their formula just 1? Yeah, well, there's also that, like the coefficient of the first one is always 1. But notice that they, instead of a and b, they have 1 and x. And 1 to the power of n is just going to end up being 1. So you're right, it's because the first coefficient is 1, because it'll be n0, which is 1. Plus also this to the power of any value is going to be 1 as well. So now enough of that business. Let's just move on to actually doing some real ones. I tried to include some more challenging ones that are sort of a little bit, this one's not too bad, a little bit in the style of some of the ones in your textbook. Like see how they're a bit more challenging because you've got fractions. So you still do it in the same way, you just have to be really careful, go super carefully. Use the binomial theorem to expand each expression. I personally don't like having a negative at the front, but it's not wrong if you have a negative at the front. Do you want to leave the negative at the front? Or you could swap it around to 3y minus 2x instead. Do you want to just do it this way?
Sure.
Yeah, let's do it. Let's challenge ourselves and let's just leave it in this order. Because when you combine everything, it needs to be in alphabetical order anyway, doesn't it? You'd need x first and then y. So when I first did it, I swapped them over, but then I had to swap them back again. It's just so difficult. Okay, the exponent is 5, so how many terms will there be in the final expansion? 6 terms, yep. So 6 terms in the final expansion. And I've kind of got to get you back into the habit of writing them out like this. So 6, 0, what's that going to equal? 1, yeah. First term in Pascal's always 1. 6, 1. You could do it on your calculator if you weren't sure. Can anyone just memorize what are the 5 terms? The 6 terms? Yeah, it is. If you remember it, that's great. If you forget it, remember you can do NCR on your calculator. 6, 0. So the next one's going to be 5. I sort of just have to get you in the habit of kind of like seeing it written out like this. So Next one will be 6, 2, which is going to be 10. 6, 3, which is 10. Dot, 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 dot. I've run out of space. The rest you could write up. 6, so that one's going to be 6, 4. That'll be, no, that's 6, 4. I know it's right. What have I done? Have I missed something twice? 6, 3, 0, 1, 2, 3. Oh! No! Yes, I did this wrong. This is right, this is fine. This number here is wrong. Sorry about that. I wasn't concentrating. It's 5, yeah. Sorry, if that was confusing you, I'm very sorry about that. Yeah, I do that sometimes. That should just be 5. That should just be that. I saw that number there instead. So the reason I knew something was wrong is because I knew this one had to end up being the last one. And if we continued 6, 4, then there'd still have to be a 6, 5 and a 6, 6. So that alerted me to the problem. Hang on. It's meant to end there. So that's going to be 5, 4. That's going to be 5, 5. Which makes a lot more sense. But sometimes forget that. So that's the danger of writing out this. Sometimes you can think that it's 6, but that thing is that thing. And so on. And now we just start to write out our lovely little expansion. I'm going to put, you can put the number 1 first if you want. So just, you don't need to if you're familiar with this, but for the sake of the people that have been away, I'll put it there. And in brackets, red and blue, would you agree negative 2x is the first term? What should it be to the power of? 5. Yeah. And this one's to the power of 0, which is just going to become 1. And next coefficient is plus 5. And remember, powers of this one are descending by 1. So what's going to be the exponent on negative 2x? 4. 4, yeah. So see, the brackets are really important because it's to the power of something. And then I've also got to factor in my 3y. What's going to be in my exponent on my 3y? Yeah, just 1. Yes, you can leave it, or you can write the 1 if it helps. Yes, so feel free to continue on if you want. Just have to go really carefully. So the brackets are mega important. When this expands, will the last term be 3y to the power of 5?
No.
No. What did I forget to do? Is it 15y to the power of 5?
No. 3 to the
Yeah, I forgot the fact that it's 3 to the power of 5, y to the power of 5. Anyone off the top of their head happen to know what 3 to the power of 5 is? 3 to the power of 4 is 81. So 3 to the power of 5 will be?
So why is it not negative 2 to the power of 5 and x to the power of 5?
What is still? No, it's 243, yep, which is 81 times 3. Yep, so if you just know 3 cubed is 27, 3 to the power of 4 is 81, 3 to the power of 5 is just 3 times that.
Why is it that again? Why is it? What?
Wouldn't we have to do that for everything else?
Yeah, you're going to have to do it for the whole thing. I just thought I'll kind of point it out on this one. So now we're going to have to keep that in mind when we do the entire expansion.
Including negative 2x.
Yeah.
Okay, good.
Yes, including that one, yeah. Sorry, is that what you're asking, Owen? You were thinking it didn't apply to that one. No, I'm talking more just so about the next line. So the next line will be when we kind of start to expand everything out. So yeah. Let's do that in purple. So negative 2x to the power of 5, is it negative 10 to the power of 5?
No.
Yeah. Is it going to be a negative or a positive term? Yeah, because it's to an odd power. So it's going to be negative. What's 2 to the power of 5? 32. So hopefully you'll get really good at your powers of 2 and 3. Because there's heaps of that in this topic. Lots and lots of powers of 2 and 3. Yeah. And then overall we've got to decide is this term going to be positive or negative. This is, yeah, good. This is to an even power, so that's going to be positive. So we know it's going to be a plus.
Would it be 16 times 5?
Yep, 16 times 5 times 3. 16 times 5 times 3. I did 16 times 3 times 5. I did it the other way around. 240? Yeah, it is 240. And I'm going to plant. Don't forget, I'm going to put a mistake there. So what mistake have I just put?
X means power.
Yeah.
4.
X is to the power of 4. So little things like that can get mixed. Overall, will this term be positive or negative?
Negative.
Okay. It's an odd power. Negative times positive, positive. Is it 60? No, it's not 60. Is it?
Negative 8 times 9 times 10.
Close. Negative 8. Oh, yeah, times 9 times 10. You're right. So 8 times 9 times 10. Could you do that in your head? 720. Good, yeah. 8 times 9. Just practicing doing the non-calc stuff. 8 times 9 is 752 times 10. X cubed y squared. So see how powers add to our exponents on these terms add to 5? 5, that's good. You're probably seeing a bit of a pattern, so it's going to be positive. So positive overall, because we've got an even power. 2 squared times 3 times 10.
1,080. 1,080.
Yeah. Oh yeah, sorry. No, yeah. 4 times 3 cubed. That's what I did by mistake. 4 times 27 times 10. Good. Pretty awful. So at least that's in there. 1,080. So see how that kind of stuff can happen? You can end up by forgetting that that's 3 cubed. That kind of stuff can happen. If it helps, write the number stuff out on the side if you want. And then x squared y cubed. Overall, you've probably seen a pattern. Positive times a negative times a positive. So take away. What's 3 to the power of 4?
81.
81. Yeah. And 5 times 2 is 10.
1 times.
Did you get it?
Negative.
Okay, cool. Yeah. And then don't forget that there's just an x. That could be easily missed. That exponent at the 5. It's quite grueling, isn't it? And then we already talked about this one. So I'm going to put a common error there. People get tired by the time they hit the last term. So my brain got tired, and what did I forget?
The power of the wall.
Yeah. So a little overall check. You could check, are your powers of x descending? Your powers of y ascending? That's easy enough. So, yeah, does that seem like a lot of work?
Yeah.
Yeah, so just going really carefully. So as I said, lesson 4 is more when they just ask you for a single term. And that's what they tend to do in the exams, because then they don't have to correct all this stuff. They just want to check, did you get that term right? Good. So that's lovely, that's all done. Are you cold now? Yeah, I put it back on, so it's really in there hot. So now that's better. That's cool already. So as I said, that's an example of a straightforward one. If anything, what was tough about it, yeah. If anything, what was tough about it was a high power here, as opposed to a 3 or a 4.
So long.
Yeah, it was pretty grueling. So this is where your algebra is going to be tested a lot. Why isn't this moving down?
I'm not hard.
I don't know.
So embarrassing.
I think it's frozen on me. Oh. It's frozen on me, hasn't it? Yeah, it's frozen. Okay, I just paused. 7, cool. Here we go. Next example. What's a bit nice about it is we've got the exponents only 3. Nice. Yeah, the exponents only 3, but we've got fractions, so our algebra's got to be really spot on. So it's to the power of 3. How many terms will be in our final expansion? 4. 4 terms. So it's
1, 3, 3, 1.
Yeah, exactly. It's 1, 3, 3, 1. So if you remember that stuff, that's great. 1, 3, 3, 1. That's a pretty good one. Yeah, 4 terms. If you had to write it out like this, though, you have to go 3, 0 equals 1.
Should be 3, N, 0, and then 3, N, 1, and that was okay.
Oh, like 4C NCR. It'd be like 3C0, 3C1, 3C2, like that. If you want to write it like that instead, you can. So feel free to write it like the NCR instead style. I'm just practicing writing them in the brackety bit because that's my favourite way. The NCR is how you calculate it. You might want to write it like that instead. Equals 3, 3, 2, equals 3, 3, 3, equals 1. There you go. So 1, 3, 3, 1. Again, I'm doing this because I want you to practice writing it out like that as well, because sometimes I like to do that when you're working out. Sometimes teachers will ask you to put it in your working out like that. So I'm okay if you want to write it out the top like that, then you don't need to. You can just go straight to using those numbers if you prefer. Yeah. Okay, so our first term again for the sake of the new people, I will write 1. Normally we don't bother to write the 1 because 1 times anything is just a thing. 1e, is it just e?
Yep. E cubed.
E cubed, good, yeah, e cubed. What colour did I use for the first one? I used blue. E cubed. And 5 over d to the power of 0 is just 1. And it's plus. The nice thing about it is when it's plus, every term is going to have a plus in it. So when it's plus, that's nice and easy. Easy peasy. Plus 3. Squared, you probably realised it was. And times 5 over d. Okay. So the good thing is that oh. So the good thing is there's not that many terms. So when it's to the power of 3, there's not many terms to write out. Thank goodness. 1e cubed, would you agree that's just e cubed?
E cubed.
E cubed, yay. And then what will be the coefficient of the second term? Yeah, 15, just 3 times 5. So plus
3 squared. What? 15 oh.
Wait,
Why is it 15? What happened to, oh, never mind.
Yeah, good point. Why is it 15? So that's
Oh,
like
never mind,
3
I
over
got it.
1. Yeah, that's like 3 over 1, and that's like 5. So the numerator is now going to be that thing times 5. Don't forget it's all over d. Yeah, bed mass, good. So you're going to need to work out 5 squared first, and then times it by 3.
5e.
Yeah, d. Oh, d, yeah, good.
Wait, so isn't it d squared?
Yes, good. And I make those kind of mistakes. So beware. So 75, what was it again? E over d squared, good. Because 5 squared over d squared.
125.
That's good, yeah. 5 cubed, which is 125 over. Have I made another mistake again? Have I made another boo-boo?
H over H. D cubed.
Yes, d cubed. Can we cancel down at all or anything like that?
No.
Can't cancel down. Always good just to have a little look. Maybe you could cancel down, but I couldn't in this case. So you can have weird fraction answers. And save that. It's the last page, isn't it? Is it? Or is there more on the next page? Oh, that's just the beginning of L2 though, on the next page. We can just, so that's alright, we can end on this one. See, awkward fractions, ew. Awkward, so it means we have to be careful. It's to the power of 4. Can anyone off the top of their head remember how many terms will there be?
Five.
There'll be 5 terms in the expansion.
1, 4, 6, 4.
Yeah, good. 1, 4, 6, 4, 1. Again, I want to kind of make you practice writing it out. So, so the first one's going to be 4.
0.
Yeah, 4 over 0, or if you want to practice it that way too, you can do it like this if you prefer. It was 1, 4, C1, 4.
You can write it either way, the
Yeah.
SCR or the N over R.
Yeah, that's correct. I tend to see the brackety way is the most common way I've seen. Doesn't mean it can't be presented to you in this way. Like some books prefer it in this way. I just like to use that. Okay, so 4, C, 2, 6, 4. I find it's hard to write though. 4, C3 equals 4.
Well, see you.
Okay. So you could, if you prefer, write it with the brackets instead, like 4, 3, that kind of thing. I was just showing you in this example it can be written like that. I personally find writing the 2 subscripts kind of awkward to do. And then we can go straight to all this stuff. So again, let's take a look at newbies. I like the 1. Select that 1. 4, 6, 4, 1. I want to do it. You don't need to bother to write the 1. Ugh. So first time is in blue, isn't it? Oops. I was just about to write a cubed because I'm used to things just being a power of a, but would you agree it's a cubed all to the power of 4? Yeah, so be careful of that because you're so used to just seeing things to a power, so you can think, oh, that's it already. That it's a cubed to the power of 4. And it's plus this time again, so that's nice. Just everything's added.
No.
Lost track of what I'm doing. I know when the last one I'll be. Is the first one a to the power of 7? No, which would have been correct.
Wow.
A 12, yeah. Very good practice of your exponents, all this stuff. Yeah, so what would be the coefficient of the second term?
Wow.
12, good, yeah. So there's going to be a third line where I've cancelled down my a's, but I'm just going to write them uncancelled first. A9, yep. A good, yeah. And then on the next line I'm going to have that cancelled down because for me that's too much to do in one step, particularly when you get to these ones. Plus, what's our coefficient of the next one? Close? You can easily think it's 18, yeah?
54 is 54.
Yeah, it's 54, yeah. So that's a good thing to remember. 3 squared, then times 6, that's a 6. Is it, what mistake have I made here? Yeah, I forget the a squared in the denominator. That's my common error. I zone out and
And
forget
then
that.
you do another line where you cancel it.
Yeah, so I think doing all this in my head at the moment is maybe a bit too much of a brain drain, especially as you get to the higher powers. So I prefer to do this and then cancel in my last line. What's going to be our next coefficient?
36 a cubed over a cubed.
Ooh, is it 36? Is it either thing? What's 3 cubed? 27, yeah.
Oh, yeah.
Yeah, easily done too. 27 times 4 is? 108, did you say? Is it? Yeah, 108 probably. 108 3 cubed over?
A cubed.
Yeah, good. Okay, so that's that.
3 and 12 over a.
Yeah, it is 81.
It's over, okay. Oh, is it 3? I keep thinking 3 times 4.
Yeah, easy to do. 3 to the power 4, and that's up. And then we cancel down anything. We can't A12, obviously this stays A12. 12A9 over A.
12A9 over
Yeah. Yeah, 12A8, that's right. Subtract the exponent. Plus 54. What's our power of A this time?
3?
4. 4. Yep. Yeah,
Okay, because I was confused if you divide by 2 or you just take away 2.
Yeah, subtract it when you divide numbers that with exponents that have the same base. You subtract the exponents and get the same base, yeah. Yeah, good. 54, 8 over 4. Plus 8. What's our exponent on A this time? 0, yeah, and 8 over 0 is just 1. So that's just 108. And nothing can really be cancelled down here. So what you should be doing tonight is you should be, if you haven't already, you should be doing the little exercises. What are they again? 6MNO. 6MNO if you want to. They're really short. They're not long. 6M. Oh, you need a book, Calvina. 6M, N and O. I think I've got a book in Miss McMahon's office. I'll just. It's 12:19. I can run and grab it. So James and Calvina, you just stay here for a sec. I'll just come back with a book. So at home you should be doing exercise 6MN at least. Have I got that right? 6MN. What are you doing? Oh, right.
Get your steps. Look at the world. You're welcome, Katie. Thanks. We have to do. Probably do we have no, my student. Stop that. We will stop. Invest in the data. You think? Yay! They're in my size.
I just bought those like 2 days ago.
That's great. I'm gonna get the red ones.
The boogie for you!
And so what's nice is the awesome cooking on the back. So do you have a oh good, because I've got it up. So now here, just make sure I'm not giving you the one. Oh, that's it. Not very much though. Okay. Oh, I have a book. Does it have, the thing is, does it have those two? Is it missing paper on that one? Yeah, just take it. Okay, yeah, you grab it then. There you go. You don't use it, that's all of it. No worries. So I record these and I post them on White Lights, and so I'll just recommend it to you. And then we'll see what stuff. I'll probably recommend you just use my language folder and just go to the back and work it and take it. So then you can see what you do. Yeah, so easy enough to catch up on them. So that might be what you want to do tonight. You don't worry about the textbook exercises unless you want to go straight into it. Occasionally in the lessons there might be something that I haven't mentioned in here, but it's good to practice. Yeah.